Welcome to the DSA playlist. So in this session, we are going to solve the problem Jump Game Part 2. So this is very similar to the Jump Game Part 1 problem which we have discussed earlier. I recommend you to visit that video to understand this problem in a much easier fashion. So let's try to understand what is this particular problem. So you are given an integer array nums. Let me explain it using an example, that is 2 3 1 1 4, and as a player you are standing at the 0th indices. I can also mark the indices 0 1 2 3 and 4. And if you are standing on this 0th indices, the element represent the freedom or the reach, how far you can jump. If it's 2, you have the freedom to jump 1 position. Also he has the freedom, you can jump up to 2 positions. If you were standing at this location, then you would have had the freedom to jump from 1 positions. You can jump straight to here, or you could have jumped straight to here, or even you could have jumped straight to the last location. That much power is denoted by this particular number. And the problem demands is that you can jump, you can choose whatever as the game prescribed, but you should reach to the end indices with minimum number of jumps. So we can see here, if I'm standing here, if I choose a path, something like I jumped here, so there is 1 jump already happened, and this gives a freedom to jump 3 times. So I'm using the full capability and I'm jumping here. This is the 2nd jump, and I have already reached the end points. So in 2 jumps I have satisfied the final condition needs to be achieved. But if I had chosen something like that, something different, if I choose to jump from 0th indices to 2nd indices, taking full capability, and from here I only have capability to jump 1 location. From here I can again jump 1 location. Here jump 1, jump 2, jump 3. So the path here below is better than the path above, because here only 2 jumps. Here you could have taken 3 jumps to reach to the final location. So out of all the possible scenarios where you can design the path or the journey, you should design in such a way that should have a minimum number of jumps, and you have to return that minimum number of jumps. Here it is 2 jumps, you have to return this particular number. That's what the problem statement expecting. I hope you have understood the problem and how we can solve this particular problem. One thing is, you can use brute force method, like you can go through each and every possible path, and while going through each and every possible path, just have a track of the number of jumps, and out of all the possible paths, which path giving the least number of jumps, you have to return that particular jump. So you can solve it recursively. Like I can say that if you have chosen to transition from 0th indices to the 1st indices, this will give you a freedom to jump from 1st indices to 2nd indices, also from 1st indices to the 3rd indices, also 1st indices to the 4th indices. If you would have chosen to jump from 0 to 2nd indices, that would have only 1 freedom, that is to jump from 2nd indices to 3rd indices. And further if you calculate, like right now in this particular journey path you are at indices 2. So here the second indices will give you freedom to jump to third, and third will give you indices you can jump fourth. So you can clearly see that here in this case 1 jump, 2 jump, 3 jump, 3 jumps has been done to reach up to there. For if you see in this path, there's only 2 jumps. So you should recursively write down to go through each and every path. So what could be the time complexity here? I am not going to code this particular thing, because this eventually if you are trying to like implement in some of the programming competition or something like this, will give you time limit exceed error, because it has much more complexity. So what could be this? So in each jumps or locations, see here it give you 3 ways. And here there is only 1 ways. So basically the branching happens exponentially, and the branching number depends on the element value of the array. If it was something like 5, then you could have 5 branchings, like that will take you to 5 different locations in the array, and based on that particular value, if it was x, that would have x branchings again. So in a much general fashion, if I am going to write the time complexity, that would be x to the power n. This x, for a notation purpose, can have the average value of branching. You could have taken something like that. And the space complexity will depends upon the recursive depth, like how much stack it is going to handle and everything. Here it is at the order of n. So I am not going to code it here. If required, one could try by self, but there is a better way than this brute force method. And what is this better way? Is using greedy optimal solutions. So for that better solution, I am going to write that nums again. 2, 3, 1, 1, 4. I am going to traverse through the array. For that I am going to place this pointer I here. This will be traversing through the array, and initially I am going to set jump equal to 0, and furthest I am going to write far, another variable, set to 0. Then what I am going to do is that if someone is standing at I, how far it could jump, that would be I plus nums of I. I am going to update this far in such a way that as we traverse, far would be equal to maximum of the existing further value and this I plus nums of I. And I am also going to set another variable that is called end equal to 0. And whenever this I would encounter this end, that point a jump will happen. When I equal to end, that point a jump will happen, and the end will be assigned by the furthest we have calculated. We can dry run and understand what I really meant there. Here initially I equal to 0, end is equal to 0. So here a jump will happen and end will be assigned as
okay. I found this on the web for.
And the end will be the furthest. What is that? That is, here end is furthest, and that is 1 2 here. This indices 0 1 2 3 4. So end will be assigned here as 2, and next jump only happens as I approaches this 2. That moment only this another jump will be counted, and by that time there is one more thing. End is getting updated to the furthest, but the moment it reach here, the furthest would have taken something larger value at here. So furthest would have been updated something like, currently furthest is 2. There will be comparison between 2 and 3 plus 1, that is 4. So the end will be updated as 4. So this will be the end position. But as you iterate, we are not going to reach up to here. We are only going to iterate up to here, because from this location we don't need to jump. So that will be the end in this particular example, and the jump count currently would be 2, and we are going to return 2. So this is a very easy solution we can think about. You will understand it much better fashion when we code it. Let's code it. So this is the class solution, and method inside the class define jump. Self, what is given here? Nums is given, that is a list of integer, and we have to return the minimum number of jumps, that is another integer. I have set jump equal to 0, end equal to 0, and further equal to 0. These three things happen, and I am going to traverse. For I in range of length of nums minus 1, we are not going to count the last indices, that's why I am going to write here. And here I am going to update the further in such a way that maximum between the existing further and I plus nums of I. So the moment the I equal to, if I equal to end, that happens, that's the moment where we are going to jump plus equal to 1, and the end will be reassigned as the furthest. Once this is done, we are going to calculate the minimum number of jump to reach to the end location, and we just have to return jump. So what is the time complexity of this particular example? So time complexity is, we are only traversing it one times. So the time complexity is order of n, and space complexity is order of 1, because no extra space has been used. This is much better than the recursive method where we use the brute force approach. So I have explained this particular approach using a dry run using this particular example. I hope you have understood this particular solution, because this particular problem is not that intuitively understandable, but I have tried my level best to explain this particular problem. I hope you do understand the concepts and everything, and with that I am concluding. Thank you. So that's it.